Manisha, in 2 minutes I will start the class.
Okay, ma'am.
Today's topic of discussion is uh, Chapter 7, Unit 1, Resource Virtualization. Let us understand what is virtualization, why it is needed, and how to establish virtualization in the context of cloud.
Ma'am, screen.
Oh, yeah, thank you. Try to understand the traditional computing environment where you have physical resources. What are the physical resources? Can you tell me? And
Hardware components.
yes, what are they?
mm, Storage
CPU,
devices.
yeah, storage
Network
devices,
devices.
yes, processing devices, networking devices are the physical resources. So in traditional, this is the scenario of traditional computing. In traditional computing, we have users here, and these user access the physical resources directly. And if it is a individual machine, a desktop system, or a personal computer, at one time only one user will be accessing the physical resources. Now, for instance, my laptop, I am only the user of this laptop. Then, uh, what happens is the effective utilization of the resources may not happen in this type of environment because there is only one user using all the physical resources that are available in that particular system. So what we can do, we can go for virtualization in cloud environment. Okay, in cloud we use virtualization, but before looking into cloud, let us look at virtualized computing environment. This is traditional computing environment. So virtualized computing environment. In this what happens? You have physical resources. On top of physical resources, a layer of virtualization is created. Then you have virtual resources. And users access them. So in this scenario, what is happening? This is very important layer. Here I give you a traditional example of Unix server. In a Unix server, several clients are connected, and this server uh, provides service to all of them. So what is happening here is there is only a single server. It is serving to multiple clients, and you are creating a virtual kind of environment with which every user gets the compute power, storage power of this server. Here, this is an example of a personal computer, a single user using a personal computer. All the resources are available only to this user. In this environment, we have multiple clients that are connected to this server, and this server is providing simultaneously the services to all of them. So, how is it possible? Server is only one. How is it possible that server can do all the tasks? Because of virtualization. Virtualization refers to the representation of physical computing resources in simulated form through software. These are the physical resources. These physical resources are simulated in the form. Here at this layer we'll create a simulation, and then uh, here you have, suppose, a CPU. This CPU will now serve to multiple users through this. This layer, virtualization layer, creates three instances of this CPU. CPU is one single entity. Here you have only one CPU serving to a single user. Here you have one CPU serving to multiple users because of virtualization. So, virtualization refers to the representation of physical computing resources in simulated form through software. A layer is added here. This layer will take care of giving this resource to multiple users at the same time. This is the introduction to virtualization. Let me write down quickly virtualization. Virtualization definition, please remember, it is very important. It is the soul of um, cloud computing. This it refers to representation of physical computing resources of physical resources in simulated form through software. Okay. Is the introduction to resource virtualization clear? Let us go to the next. Virtualizing physical computing resources. How it is done? Virtualizing physical computing resources. So this is done by transforming physical units through a layer of virtualization into multiple instances. There is one,
Hello, ma'am.
yes,
We know physical resources we just discussed. What are virtual resources?
okay, virtual resource means um, for instance, now you are physically somewhere else. I don't even know where you are at present, at which geographical location you are. And you too don't know where I am. But virtually we are present. You can hear me, I can hear you. And if we switch on video, you can see me, I can see you. Virtual presence means it is not physically there, but it exists in some form. Uh, um, One more example which I can give is here there is one processor. Okay, this is our processor, and this is our memory, and this is our disk. So these are physical hardware resources. These are physical resources. Um, if there is only one user directly connected to this hardware, If this user directly access this, directly access this processor, this memory, and this disk, then it is like physically accessing. Mm, Virtually accessing means this is our processor, this is memory, and this is disk, and then on top of this you are creating a environment, virtual environment, and then it appears this is processor, this is memory, this is disk. This is a layer of virtualization. Then this processor, they are physically, how many processors are there? Only one. Virtually, how many are there? Three. Three processors, for instance, two memories and three disks. How many users can interact now? This several users can interact. Okay. I will think about some real world example to give. Okay. Do you know about video conferencing call? In that, what happens is, um, physically there is only one single phone, but through that single phone, you are at the same time interacting with multiple people. How is it possible here? Suppose you are here, your friend is here, you have one device, mobile phone. He or she has one mobile phone. This is smartphone. So physical connection means, what do? You dial a number on this smartphone. Which number? This your friend's number, and connection will be established, and then uh, this your friend will pick up the call and start interacting with you. This is physical, because you're using this resource physically only once. But then suppose if at the same time your this friend says that let us have a group chat, then you start this person also has a smartphone. Only with this one physical device you are able to connect to this person, and these two are also connected, and you can connect one more friend of yours. Look at this, what is happening with, if there is no video conferencing facility, not video, I think audio, even video also you can do, but then if you don't have conferencing facility, if you don't have this conferencing facility, you can interact with only one person at a time. How this is possible to interact with multiple people at the same time? Because this is your mobile. This is mobile means hardware. You have all chips and other units in this mobile phone, and then you also have a software in your mobile phone, which will function as a conferencing software, or you can call it as a virtualization layer. Because of this virtualization layer, you are able to connect to, if there is no virtualization layer, if you have a mobile without virtualization, you can connect with another mobile only to one person at a time. But because of virtualization, many people can connect with many people, or you can connect with let us take like this, you can connect with many people. Yes, does this make sense to you?
Yes, ma'am.
Hmm? Cleared your doubt?
Yes, ma'am.
Hardware device mobile is one, but if there is no conferencing facility, you cannot connect with multiple users at the same time. You otherwise you have to have multiple hardware devices essentially. Okay. So, what are the business benefits of virtualization? This is all about abstraction. You have to understand this is about abstraction. What do you mean by abstraction? Abstraction means um, you as a person, you have so many layers, is it not? You are having one kind of behavior with your best friends, one kind of behavior with your friends, one kind of behavior with your with strangers. This is you. You have different layers. Do you start talking with a stranger in a similar manner as you talk to your best friend? No, because there are certain things which you are not supposed to share with anyone. You trust your best friend and you both share some cordial relationship and then you both share with each other. So this is known as levels of abstraction. Like that, you also have levels of abstraction here in our computing world. At the bottom level, you have hardware, and on top of hardware, you have virtualization. On top of virtualization, you might have some other applications. Hardware is the crudest form with which you can interact directly. And then there are several business benefits because it improves the flexibility and availability of resources. If you don't have this facility, if you don't have this conferencing facility, if you there is a group, friends group, what you have to do individually, you have to call and inform about something. If suppose you group friends are planning for something, you have to do it individually. Because of this facility, simultaneously you can interact with anyone, everyone, and then you can get your points across, discuss the things with everyone. And then you have machine level or server level virtualization. Machine level or server level virtualization is the concept of creating virtual machines or virtual computer on actual physical machine. Again, let me give you an example. This is machine or server level virtualization. So machine level is also known as server level virtualization, and it is a concept. This is a concept of creating virtual machines on actual physical machine. Concept of creating virtual machine on physical machine. How is that done? Let us look at the figure. You have a processor, you have memory, you have disk, and then on top of this hardware you have operating system. I'm talking about conventional environment. On top of operating system you have applications. It means that there is one user interacting with all of the hardware. Okay. When we talk about machine or server level virtualization, you have processor, memory, and disk. And here, on top of it, you don't have operating system directly. Instead, you have layer of virtualization. In this layer of virtualization, you have machines built. Means these machines are virtual machines. They are not physical machines. This is machine 1. This is machine 2. So here, this machine will assume that it has all the three hardware resources. This is known as guest OS. Guest OS. And you have applications. This here also this is guest OS and applications. And if you observe here, there is only one instance of processor. But through virtualization, you are you are making it available to multiple users, and this is known as a virtual machine. And this here these are actually physical devices. And then now what happens? Multiple users can interact with this. Okay, let me give you another example. Um, you have your Gmail account. All of you have your Gmail accounts. Your, is a separate server maintained for individual accounts? No, no, right? You have only one server. In that one server, millions of users' data is stored, and then you don't know that you are sharing the server with which users along with your data, with whose data is stored you don't know, along with the processing your request whose requests are processed besides yours you don't know. So you are actually working on virtual machine, not on the physical machine. But when you work on your own laptop with which no one is connected, that is known as physical machine. Okay, understand students? And this layer of virtualization, this layer is is also known as hypervisor or virtual machine monitor. Hypervisor or virtual machine monitor. Do you understand? Please remember this terminology. Layer of virtualization is also known as hypervisor or virtual machine monitor, VMM. And then what are the techniques for machine virtualization? Next we'll look at machine virtualization techniques. Okay, there are two different techniques of server or machine virtualization. Machine virtualization is also known as machine or server virtualization techniques. There are two different techniques. They are hosted approach and bare metal approach. Hosted approach and bare metal approach. Let us look at the first one, which is a hosted approach. Hosted approach is uh, you have physical computing resources. On top of it, you have host operating system. And on top of it, you have hypervisor or virtual machine monitor, which is nothing but a layer of virtualization. And on top of this is your this is physical, this is host operating system, this is hypervisor or VMM, and on top of this you have virtual machine 3, virtual machine 2, virtual machine 1, and on this virtual machine applications are built. This is an application built on virtual machine 1. This is an application built on virtual machine 2. This is an application built on virtual machine 3. This is known as hosted approach, in which the operating system is installed uh, over the host machine, and this is known as host operating system. This is our machine comprising of hardware resources. On this machine, you are installing This is known as host operating system. On on, on directly hardware resources, you are installing operating system, and on top of operating system you install a layer which is nothing but a layer of virtualization, also known as hypervisor or virtual machine monitor. On top of virtual layer you have virtual machines and virtual and applications run on them. The whole idea is reusability. You have only one physical instance, you are making it available to several users through hypervisor. One processor serving to multiple clients, and all multiple clients will get the simulation environment. It's not physical environment in which a user is directly connected with the hardware. The benefits is the host operating system supplies the hardware drivers for the underlying. Here, this operating system will provide the hardware drivers, and because of that, uh, it is easy to have a hypervisor installed and make it available for virtual machines. The drawback is this hypervisor does not have direct access to physical. This direct access to physical is not available. Host operating system has direct access, whereas hypervisor does not have direct access. Hypervisor has to go through host operating system to reach the resources. This is hosted approach. And then next type, this is first technique. What are we studying? We are studying the techniques of machine or server level virtualization. Machine or server level virtualization. This is first one, hosted approach. Second one, bare metal approach. Hosted approach means you have physical resources. On top of physical resources, operating system is installed, and on top of operating system, hypervisor or virtual layer virtualization has been installed, and on top of that, you have virtual machines. Next one is bare metal approach. This is second one, bare metal approach. In the bare metal approach, can you tell me what may be the architecture? Students, are you able to understand or not?
Yes, ma'am.
Tell me what is bare metal approach. What is hosted approach?
Mm, it's not directly accessing physical
Yes, what is not directly accessing
resource.
physical?
Virtual layer not accessing directly. It's
Yes.
not accessing physical resources.
Hmm.
But I think we already we have another means bare metal means we are directly accessing them.
Very good. Bare metal approach means you are removing the host operating system layer and you have physical computing resources. You have hardware, processor, memory, disk. On top of it, you have hypervisor or also known as VMM, virtual machine monitor. And on top of it, You have virtual machines. So you have virtual machine 1, virtual machine 2, virtual machine 3, and this app is running on virtual machine 3. This app is running on virtual machine 2, and this app is running on virtual machine 1. You don't find host operating system in this model. That is removed. So what is the benefit? The benefit is that hypervisor has direct access to the hardware resources. What is the drawback? The drawback is hypervisor will have limited set of drivers, so this hypervisor can access limited number of physical devices. uh, they cannot access all, so they can support only limited hardware and cannot run on wide variety of hardware platform. Whereas in this one you can see we have host operating system that installs hardware that installs device drivers for different hardware, and thus hypervisor can work on any platform because there is a host operating system in between. Here the advantage is um, hypervisor has direct access. However, it can't support variety of hardware platform. Okay. The next topic is
Ma'am, which one is better technique then?
it depends on your application and the see Manisha. Uh, we are not creating cloud. Who is creating cloud? Cloud providers, vendors. They are creating the clouds. So you will find both. Uh, okay, I will give you example. You will find both implementation based on your application and based on your requirement. You can choose. Okay, so this hypervisor acts as a low-level virtual machine monitor, and it is also called as Type 1 hypervisor. This is known as Type 1 hypervisor or VMM or native hypervisor. Type 1 hypervisor or native hypervisor. And example is VMware's ESX. VMware. This is a type of cloud server service, and ESX and ESXi servers, and Microsoft's Hyper-V. Actually, this Hyper 5 and Zen. These are the examples of bare metal hypervisors, and this it depends if you have to run your virtualization directly on physical resources without requiring host operating system, you go for second approach. Otherwise, you have to have first approach. This first one is referred to as hosted approach is referred to as type 2 hypervisor. Type 2 hypervisor or hosted hypervisor. It's also known as hosted hypervisor. And Examples are VMware Workstation, VMware Workstation. Both are available in the market, and Microsoft Virtual PC. These are the examples of hosted approach. If you want to have your application run on several variety of hardware, then you go for this um, hosted. If you are okay with the limited hardware support, then you go for the bare metal approach. Next one is hypervisor or virtual machine monitor. What is it? We will explore now hypervisor based virtualization approaches. So this is nothing but exploring hypervisor or virtual machine monitor. So this will present a virtual operating platform before the guest system, and it monitors and manages the execution of guest system. Because there is no operating system in this, it itself will monitor and manage um, the execution of guest system and the virtual machine. And here all have to have, please observe here because we have a host operating system, this hypervisor can work on multiple physical computing resources. Whereas here it is direct, so it can execute only on single kind of physical environment. So hypervisor based virtualization approaches are divided into three categories. So hypervisor based virtualization approaches. And there are three categories. They are, first one, full virtualization, para virtualization, and hardware assisted virtualization. Okay, I will complete all the three today and then we will stop today's class. So, full virtualization, first first type is full virtualization. What do you mean by full virtualization? In this, the hypervisor fully simulates or emulates the underlying hardware. Virtual machines run over virtual set of hardware. Let us look at the figure for this full virtualization. You have host machine, on top of it you have hypervisor, and on top of that you have virtual machines. This is virtual machine 1, 2, 3. So let us give our names: virtual machine 1, virtual machine 2, virtual machine 3. In each virtual machine you have guest OS and you have applications. Okay, this is full virtualization. You can observe here the guest operating system directly run over hypervisor. Here guest operating system is running over hypervisor. This is known as full virtualization. Next you have para virtualization.
Then host machines means physical resources.
Host machine means yes. Host machine means physical. Yes, very good. Host machine means physical resources like processor, memory, RAM, disk. That is nothing but host machine. On top of that machine means physical. Para virtualization. In this, you have host machine means physical resources, host machine, and you have hypervisor, and then you also have multiple virtual machines. This is our machine 1, machine 2, machine 3, and if you observe here, after I put here the concept, you tell me what is the difference between full and para. Okay, can you identify the difference between full and para? Yes.
Is that para virtualization? Is that a modification, ma'am? Guested OS modification. What?
Yes. Yes,
Only
yes, right. You're right. What does it means? Here, guest operating system directly interacting with hypervisor without any modification. So they both can understand each other. Here, it's not the case. Guest operating system has to be modified in order to interact with hypervisor because they both cannot speak the same language. Modification has to be done. Okay. And hardware assisted virtualization means this here. So far, whatever. Yes.
OS and hypervisor can't speak same language. Means then in full virtualization, how can we do that?
It is possible even they both understand each other. If suppose they are programmed in the same language and they know everything about each other, then
Oh,
they can talk. In certain cases, they may not, so they can't talk.
that
There
we
are
call it
there are few people.
virtualization.
Yes, there are few people who know one language and there are few other who know another language and they both can't speak directly. Some people, one Chinese is there, one French is there. Okay, if they speak the same language, they can talk directly. Okay, so next, the last one is hardware assisted. In hardware assisted virtualization is about having having virtualization built directly into the hardware. So far, whatever we saw, they are implemented at the software level. But suppose if you have to implement the virtualization directly built into the hardware. For instance, this is our processor. Okay, in this processor, it understands only single user at a time. It's not virtualized. And there is another processor. This in hardware itself on the board, you include certain circuitry that understands the meaning of virtualization. So this hardware only is able to serve multiple users at the same time. This is known as hardware assisted virtualization. Okay, Manisha, we will stop our class here. Tomorrow we will study operating system level virtualization. You please go through from page number. Textbook is available from page number 111, page number 1112, 122. Please go through this
Okay, ma'am.
and then tomorrow we will resume the same concept of virtualization.
Okay, ma'am.
Okay, bye.
Bye, ma'am. Thank you, ma'am.